Hi guys, welcome back to our channel Shamku Sparks. So ఇవాళ మనము ఇంటర్మీడియట్ ఫస్ట్ ఇయర్ ఫిజిక్స్ చాప్టర్ 9 గ్రావిటేషన్ కంప్లీట్ చేసుకున్నాము. సో ఇందులో నుంచి మనకు అకార్డింగ్ టు బ్లూ ప్రింట్ ఒక 4 మార్క్స్ క్వశ్చన్ వస్తుంది. సో మనము ప్రీవియస్ పేపర్స్లో మనకు ఇంపార్టెంట్ అండ్ మోస్ట్ రిపీటెడ్ క్వశ్చన్స్ అన్నీ కంప్లీట్ చేసుకున్నాము. సో మనము ఫస్ట్ ఇంపార్టెంట్ క్వశ్చన్, వాట్ ఈజ్ ఆర్బిటాల్ వెలాసిటీ, obtain an expression for it. సో ఈ క్వశ్చన్ చాలా ఈజీ, జస్ట్ మనం ప్రాక్టీస్ చేస్తే మనకి ఈ క్వశ్చన్ ఈజీగా వచ్చేస్తుంది. ఓకే, సో ఆర్బిటాల్ వెలాసిటీ, ఫస్ట్ ఆర్బిటాల్ వెలాసిటీ అంటే ఏంటి? ద మినిమం వెలాసిటీ రిక్వైర్డ్ for an object to revolve around a planet in a circular orbit is called orbital velocity. Okay, so మనకి ఇక్కడ orbital velocity definition, after that orbital velocity expression రాసుకోవాలి. ఓకే, so gravitational force Fg is equals to gmm by r plus h whole square. Centripetal force Fc is equals to mv naught square by r plus h. Okay, so therefore mv naught square by r plus h is equals to gmm by r plus h whole square. Same terms will be cancelled, r plus h and square. సో ఇక్కడ మనకు 2r plus h ఉంది కాబట్టి ఇక్కడ ఒకటి క్యాన్సిల్ అండ్ ఇక్కడ ఒకటి. సో ఇక్కడ మనకు 2 నుంచి ఒకటి పోతుంది కాబట్టి సో 1 will be remained. So m and m is cancelled. So the remaining terms v naught square is equals to gm by r plus h. So therefore radius is much more greater than height. So that's why v naught square is equals to gm by r. So therefore square at side వెళ్తే రూట్ అవుతుంది కాబట్టి సో v naught is equals to root gm by r. So therefore g is equals to gm by r square. సో gm ఫార్ములా కావాలి కాబట్టి సో gmని లెఫ్ట్ సైడ్ తెచ్చేసుకుంటే సో gm is equals to gr square. Okay, so in the place of gm we have to take a substitute gr square. So v naught is equals to root gr square by r. So here square and r will get cancelled, square and r will get cancelled. So the remaining will be v naught is equals to root gr. So this is the orbital velocity derivation. So let's move on to the next question. What is escape velocity? Obtain an expression for it. So first, what is escape velocity? The minimum velocity required for an object to escape from gravitational field of planet is known as escape velocity. So let's derive the expression. Kinetic energy plus potential energy is equals to 0. So we have to మనం ఏం చేయాలంటే ఈ పొటెన్షియల్ ఎనర్జీని రైట్ సైడ్ తెచ్చుకోవాలి. సో కైనెటిక్ ఎనర్జీ ఈజ్ ఈక్వల్స్ టు మైనస్ పొటెన్షియల్ ఎనర్జీ. దిస్ ఇస్ ఈక్వేషన్ నెంబర్ 1. Therefore potential energy PE is equals to minus gmm by r and kinetic energy KE is equals to half mve square. So half mve square is equals to minus of and brackets minus gmm by r, minus minus will get cancelled. So half mve square is equals to gmm by r. M and m will get cancelled. Therefore we have to write the remaining terms. ve square by 2 is equals to, this half is written as 2 here, by 2 is equals to gm by r. So ve square is equals to, this 2 will get this side, so is equals to 2 gm by r. So ve is equals to root of 2 gm by r. Okay, so therefore g is equals to gm by r square. We have to get gm formula, so gm is equals to gr square. So ve is equals to, in the place of gm we have to take gr square. So 2 gr square by r, square and r will get cancelled. So ve is equals to root 2 gr. So now let's move on to the next question. Derive the relation between acceleration due to gravity small g at the surface of a planet and gravitational constant capital G. So we have to find out the relation between capital G and small g. Okay, so F is equals to mg. This is equation number 1, and F is equals to GMM by R square. This is equation number 2. So equation 1 is equals to equation 2. So mg is equals to GMM by R square. Okay. So therefore G is equals to, here M and M will get cancelled. So G is equals to Gm by R square. So this is the relationship between acceleration due to gravity at the surface of a planet and gravitational constant. So now let's move on to the next question. State Kepler's law of planetary motion. Kepler's law. We have 3 laws. The first law is law of orbits. Every planet revolves around the sun in elliptical path. The sun is at one of the foci in the ellipse. So a planet P moves in an elliptical path around the sun as shown in the figure. Sun is at any one of the foci. Okay. So the next law, law of areas. The areal velocity of a planet remains constant. So dA by dt is equals to constant. The third law, law of periods. The square of time period of a planet is directly proportional to the cube of the semi-major axis of the ellipse. So t square is directly proportional to a cube.